Hello and welcome to the AI Engineering Podcast, your guide to the fast-moving world of building scalable and maintainable AI systems. Your host is Tobias Macy, and today I'm interviewing Matt Zeiler, founder and CEO of Clarifai, about the technical aspects of retrieval augmented generation, including the architectural requirements, edge cases, and evolutionary characteristics. So, Matt, can you start by introducing yourself?
Hey, yeah, thanks for having me. So I'm Matt Zeiler, founder and CEO of Clarifai. I founded Clarifai about 10 years ago at this point, one of the first true deep learning AI companies. And even before starting Clarifai, I was diving deep into neural networks and deep learning all the way back at undergrad at University of Toronto. Very fortunate to work with Jeff Hinton there, who people consider the godfather of AI. And that really was a little bit of luck stumbling across AI there. But once I did come across it, I was really hooked. And so I decided to do my PhD, which brought me to New York University and got to work with people like Rob Fergus and Jan LeCun, more pioneers in this field. So that was kind of the background and learning I was able to do before starting Clarifai, and lots of lessons learned over the years running the company and being a pioneer in this space.
You mentioned that you kind of fell into machine learning and AI. You've been in it for a while now. Obviously, the thing that has sucked all of the air out of the room when anybody says AI is generative models, in particular large language models. And I'm wondering, given your history in the space and the fact that you've been working in it for a while, what your perspective is on the utility and the lasting power of large language models and generative AI, and the role that so-called traditional AI or more statistical models plays in this current landscape.
Yeah, absolutely. At the end of the day, all of these models for the last kind of 15 years that have been showing promise are neural networks, including generative, or what people are now calling generative AI. It's all neural network based, which is kind of algorithms meant to simulate how your brain works. And even back at that University of Toronto days, I was doing generative models for motion capture data. It was an interesting project about understanding pigeons walking and filling in missing motion capture recordings. And so it was actually generating data, just like these large language models generate text, it was generating motion capture. And so this is not new technology. I think what has really changed over the last 15 years is the size of the models, the amount of data they're trained on, and both of those things require a significant increase in compute. And so that's why all of a sudden it's at the capabilities are understanding enough about the world that they're doing a lot of interesting properties. And so I think it's opening. We're still in the early days of exploring those possibilities of these models, and there's new ones every day. And I think it's going to be this way for many years to come. Continued growth on training size, algorithm size, and compute will just keep unlocking more and more capability.
With the rise in popularity and at least potential application, if not actual real world application for these large language models, one of the topic areas that has gained a lot of interest is the idea of retrieval augmented generation, or being able to build your own context corpus for the model to feed on to be able to actually complete the task that you want it to complete versus the general task that it was originally trained for. And I'm wondering if you can just start by giving your definition of retrieval augmented generation and some of the requirements that it brings to the architecture.
Yeah, absolutely. So I think most people are familiar with how LLMs are used today. You have a context window, which you pass in input tokens, and then you ask the model to continue generating output tokens, and all that has to fit in the context window. And the generations occur based on whatever went into the training of those large language models. And so there's a lot of problems with that. Like it gets stale whenever you last trained, is all the information it has. And so, and it can hallucinate a lot of stuff. There's not that much control in how it generates what it's going to generate. And so retrieval augmented generation came around a few years ago to help address some of those problems of giving it more dynamic access to information and improving hallucinations. And retrieval augmented generation is kind of explicit in how it actually works. So it first starts with retrieving out of a large corpus of information more fine grained information that it can stuff into that context window so that the LLM has more facts that it can use in addition to the prompt that is provided in order to augment its generation. So that's how you get the word retrieval augmented generation. So it first takes your input prompt, queries usually a vector database to retrieve most similar chunks of documents that can help the LLM augment its generation.
As you mentioned, vector databases have taken off alongside the growth of retrieval augmented generation. Another thing that is maybe worth touching on is that at the beginning of this upswing in popularity of these AI models was the idea of prompt engineering, which pretty rapidly gave way to retrieval augmented generation. And I'm wondering what you see as the overlap of prompt engineering and retrieval augmented generation, and what are the cases where prompt engineering is actually still a viable utility in the application of these AI models?
Yeah, there's kind of this spectrum of prompt engineering is the quickest, easiest thing you can try first. RAG is the second one, retrieval augmented generation. The third being fine tuning models. So taking these, popular open source models, customizing them on your data. And then fourth is kind of training new models from scratch. And the spectrum kind of gets into a question of how much compute and data you have access to. If you don't have much data, you can't really pre-train a model at all. Fine tuning is unlikely to work very well. You can prompt engineer an existing model, but it's only going to get you as far as whatever that model understands. And so RAG becomes a really good choice where you can have limited sets or small data set sizes, but still customize the outputs of the model to be more specific for your particular task and your data set. And that helps it, kind of ground these models, or I've heard the term tame these models. I like that because if you don't tame them, they can go off the rails and generate a lot of stuff that you wouldn't want to put in front of your customers. And it and it can also help these models kind of adapt to new things that have never been seen or different domains of data that they've never seen. So, for example, they maybe weren't trained on legal documents or finance documents or classified documents. We do a lot of work with the government and intelligence community, and so there's a lot of things that simply these models have never been trained to see. And so RAG can help you adapt to those, whereas prompt engineering won't help in those scenarios. And then if you really want to, get the models to perform better and continue that trend of reducing hallucination, customizing on your data, that's when getting into fine tuning and at the biggest scale, training your own specific model can come into play. But for most part, you can get away with prompt engineering and fine tuning for a lot of applications.
Circling back on the vector database aspect of it, there's definitely utility in having the data that you're trying to stuff into your context already formatted in the same data structure or the same language that the model understands. But I'm wondering what you see as vector databases being a requirement for retrieval augmented generation versus just an optimization of the functionality.
Yeah, it's a good question. The In today's most popular RAG systems, they are kind of a core component to it, but I have this feeling that it's kind of stitching together a bunch of components very loosely, and there's going to be improvements to that in the future. So stitching on a vector database to stuff text into the context helps, and there's even papers. I was just reading one this week about kind of provability that it does help with hallucinations and grounding these models. There's some theorems around that, which is exciting. So these things the RAG approach does work, but it just still feels like it's a bunch of independent components bolted on to each other. And I think what we're going to see is more end-to-end training, and we're already starting to see kind of that in the research community. And once you have that, the vector database is just one type of thing that you can query information from. You're seeing a lot of other usage of these large language models that just generally can query information from tools. It doesn't have to be a vector database. It could be an API to get the weather. It could be, your Salesforce account to get your CRM data. It could be a lot of different integrations. And so I think the vector database is just one simple one that people can get started with. But long term, I think we're going to see a lot more flexibility and a lot more kind of unified understanding, not less kind of stitching things together.
Digging further into that collection of tools that are being stitched together, can you give an overview of what you see as the typical architecture and the technical components for being able to actually bring RAG to bear and some of the operational considerations around that?
Yeah, absolutely. And this is kind of where Clarifai fits in. I realize I didn't really give an overview of what Clarifai does, but we are that AI workflow orchestration platform. So we have all the tools in one place to get you from prototype to production as quickly as possible. We often talk about it as being AI in 5 minutes, because literally with workflows like RAG, you can actually be set up and running in about 4 or 5 lines of code using our SDKs. And we have vector databases built in. We have all the embedding models you need to retrieve and index your data. We have all the popular large language models, all the third-party ones like OpenAI, Anthropic, Google, etc., and all the open source ones like Mistral, Llama 3. And within hours of new ones being announced, we're importing them into our platform so that they're ready to go for your use cases. And stitching together, a RAG has a lot of these components. You have to think about the vector database, how you want to run that at production scale. How do you want to actually like index your data? There's like the data pipelines of chunking up large documents like PDFs or large text files into small chunks before going into the embedding model. Once you get embeddings out of those, you have to decide, do you want to keep them in full precision? Do you want to quantize those embeddings, which is popular for saving memory in your vector database? How do you want to index the embeddings in your database? There's a lot of configurations there. And then once you have that kind of indexing sorted out, you have to think through, how do you actually re-index when you have one more document to add, or maybe you want to change the embedding model, like a new one comes out on a regular basis. How do you think through the re-indexing process? So there's a whole can of worms on doing production quality on the embedding and vector DB side, and that's even before you start doing RAG. Once you start doing RAG, you have to think about now the LLM or LMM if you want to go into multimodal type of models. You have to make a choice on which one's suitable from a size perspective, a cost perspective, latency perspective, and accuracy perspective. There's lots of dimensions to choosing the appropriate large model for your use case. And then you have to test it out. Typically, there's evaluations for the large language models, and there's less evaluations for this end-to-end process of having embedding vectors to retrieve, having the right indexing for that, having the right LLM, etc. And then that's kind of getting you to an MVP. Now, when you think about running in production, you have to think about monitoring, tracing. How do you collect feedback so that system gets better? The best data for any kind of AI system is feedback from real world usage. And so do you have pipelines to collect that and incorporate that into fine tuning your models, fine tuning your prompts, etc.? And then when you think about kind of enterprise grade, you have to think about what permissions does an employee have to access the data that goes into feeding this RAG pipeline? What permissions do they have to the models? How do you scale up replicas of the vector database, the embedders, the LLMs? How do you do failover? How do you upgrade whenever GPT-5 comes out, or Claude 4 or Gemini 2? How do you actually, or Llama 4, like there's always going to be new models. How do you think about the upgrade process? It becomes really, really complicated. Very easy to get started with a proof of concept for RAG, but very difficult to run it in production. And having a platform like Clarifai that has all these components and these workflows of feedback, access control, auto scaling, etc., helps people go from that prototype phase to production.
The other aspect of operating at scale is the question of what are the edge cases, what are the failure modes, and in particular, how do you fail gracefully where maybe your vector database goes down, but you don't want your AI product to just completely fail. Maybe you just want to be able to let it operate in a slightly degraded capacity. What does that look like? And I'm curious how you are seeing people address those aspects of the failure modes, recovery modes, and how to fail gracefully.
Yeah, I mean, that's the big problem with taking the approach of stitching together a bunch of different vendors, like a vendor for embeddings, a vendor for vector database, a vendor for LLMs, a vendor for monitoring. Like, if any one of those vendors goes down or their API just changes, like maybe they made a breaking change, you missed an announcement on it, your system falls apart. And that makes your experience for your customers so much less reliable. And then the other dimension you mentioned is kind of other faults that can happen in production, or just the models are still, even with RAG and helping ground them, you can run into issues where they still hallucinate. And how do you get feedback quickly from your users to catch those cases and tune things? Sometimes it may be an automated tuning, like active learning pipelines, but other times it might just be thinking about, changing your prompt, changing the context parameters or what's indexed into the database to help improve the experience for your users over time. So getting that feedback loop is really, really important to help catch these edge cases, because it's not just something you would see on a typical like monitoring dashboard or tracing dashboard. You need the actual qualitative feedback as well.
One of the terms that keeps coming up as we're talking about this is the idea of the context window. And each of these models has different sizes of context windows or the number of tokens that they can accept as context. We're talking about using these vector embeddings as additions to the context for the request. And I'm wondering how that sizing of the context window influences the ways that you think about the embedding generation, what size the chunking should be, how many records to retrieve for augmenting that generation request, and some of the ways that that context window acts as a limiting factor and a forcing function to the way that you design the rest of your overall pipelines and the data flows.
Yeah, it's a good question. And this is something that really surprises me in the last, kind of 18 to whatever we're at now, 20 months since ChatGPT came out. How many people talk about the different models that are available and details about them, like context window size? And these are like, I've had conversations with people that are not technical at all, but they have this in their vocabulary now. It's a crazy moment in time, and I don't know if that will stay true forever, but it is really interesting. The context window is important for RAG because the more context you can stuff with all the retrieved documents, the more facts and more grounding that it can do. So there's some models like Gemini is like 1 million or 2 million, I forget what it is, tokens that you can fit in. There's even new algorithms that are not just transformer based, but variants of transformers that kind of have infinite windows. They get away from having this attention mechanism that has to look at every token every time, to something that's more like recurrent networks or convolutional networks, which kind of just continually process as you go. And that opens up really long context windows and doing that processing efficiently. So I think the trend is going to be that these context windows continue to grow. But when it is limited, one component I might have missed in describing all the different possible components for RAG is a re-ranker, which can come in really useful when the context window is small. So it kind of comes into play when the query goes and retrieves documents from a vector store. It can re-rank the short list of documents to get the final subset that is stuffed into the context window. And so that re-ranker can be another AI model, and it's an additional step on top of the embedding model and on top of the large language model that can help improve the accuracy of the retrieval process. And that helps kind of when you are on a small context window to make sure that whatever you're stuffing in there is the best possible chunks of documents. And another part of your question was that chunking process. And this is I don't know if I haven't seen any good solution or perfect solution for this. It's kind of a lot of heuristics of how large you want to chunk your documents, kind of relates to how good your embedding model is at understanding the whole chunk. Some embedding models are trained kind of at the word level, at the sentence level, at the the paragraph level and at the document level. So depending on which embedding model you want to use, it'll impact your chunk size. And then it also factors into the LLM's context window size. If you have really big chunk size but a small context window, you might only get one chunk. And so you better get the right chunk in that scenario. Otherwise, it's not going to, it may actually hurt your generation performance. So there's lots of kind of parameters in that decision. I haven't seen like a perfect solution to that. But that could be an interesting area for researchers to come up with a more automated way of deciding on these chunks.
On that context of the embeddings too, I'm wondering if there's any utility in applying dimensionality reduction to be able to reduce the size or the amount of space in that context window that a single document is taking up without necessarily changing the chunking pattern or like how big of a chunk of the document you're retrieving.
So yeah, I think so. Just to clarify one important part for the listeners, the embeddings aren't used directly in a typical RAG system. It's not the embeddings that are put into the context window; it's the text itself. There are some approaches that kind of factor in embeddings as tokens, but typically you just retrieve the documents using an embedder and a vector database to get the text, and then you stuff the text into the context window. I have seen some approaches that take that text and apply things like summarization on it so that it's reducing the amount of words. Because typically, any language model, whether it's these large models or the first transformers like BERT style models, etc., that are still incredibly well suited for most use cases, they don't care about the stop words. The of throwing all that stuff out is going to save you tokens in your context window and probably not affect the generation that much. It'll have some edge cases with that because obviously there's important words like not that could change completely the meaning of a sentence. So you have to be careful in that, but summarizers are good enough that they can keep the important parts and get the meaning, and that can save you on the chunk size fitting into the context window.
The other piece of chunk size and to your point of these models that have either much larger or potentially unlimited context windows, that brings up the question of what impact does it have on the overall latency of the experience, where I can put the entirety of War and Peace into my context window, but now maybe it's going to take an hour for the model to actually give me a response. And I'm wondering how that affects the balance and the ways that you think about how large of a document to put into the request, given the fact that it may impact the end user experience.
Yeah, that's where these newer style attention mechanisms become really important. There's a lot of work in this area because everybody knows that as the context window increases, the speed, the latency increases. And so these attention mechanisms that get away from looking at every token in the context window and comparing it to every other token, which is kind of an n squared operation, and there's other overhead on top of that. These new attention mechanisms are much more efficient and maintaining, for the most part, all the performance gains. Without those, then getting to even 32,000 context window or 128,000, like the latency gets significantly slower. So that's why you see most context windows are like 4,000, 8,000 typically, especially for these small models. Otherwise, the attention just makes the models not really useful at that point.
Now, getting into the practical elements of I have an application, I want to use a large language model or some other modality of generative model. I'm going to use retrieval augmented generation. So now the first step is I have to generate those embeddings to put into my vector database. You mentioned the consideration around which embedding model to use, the fact that they're constantly changing, what are the strategies for chunking, and how often to reindex or how to append to the indexes. I'm wondering if you can talk through some of the ways that somebody needs to think through that planning and design step of selecting the embedding model, selecting the chunk sizes, etc.
Yeah. So, I mean, it all starts with your use case and the data that you have available for that use case. and then everything should fall kind of backwards from there. Because if you're dealing with, inherently small snippets of text, like emails are pretty small compared to PDFs, or 10K financial reports, which are really large PDFs. It all depends on your data, and that will dictate a lot of how you decide to chunk it, which embedding models you want to use, which large language models you want to use, maybe even the vector database. But that typically won't change depending on the type of data or the use case. There'll be other considerations when choosing your vector DB. For the embedding vector, there's some kind of open benchmarks, like the massive text embedding benchmark, MTEB, that has become popular. And you can see typically these types of things on leaderboards on the internet if you just search for embedding benchmark, and that gives you a good overview for some general purpose use cases. And those will cover things like emails, chat experiences, documentation, that kind of stuff. If you get into a domain that these models likely have not seen before, I always like to talk about these classified documents, because clearly they wouldn't have been trained on that data. So in those scenarios, you may have to run your own evaluation benchmarks on your own data set. And we provide tools at Clarifai to help you evaluate models very easily. And actually, you can create your own leaderboards. So using tools like that is really valuable, because the general purpose benchmarks are good to understand which models you should probably evaluate, but then actually evaluating them on your ground truth data sets becomes really, really important. So that'll give you kind of your embedding model from that process. And then you have to think about kind of another factor actually in the embedding model choice is going to be your compute. Do you have GPUs available that are big enough for that model? How are you going to auto scale that model? Do you have a service that's already doing that, et cetera? That becomes an important choice. Another consideration for both the embedding and the compute is also true about the large language models, both for embeddings and for the large language models, is understanding, is your data all in one language as well? English is trained into most of these models, but other languages, you'll get mixed results depending on which model you choose. We're seeing a trend, obviously, that these models are training on the whole internet, and that includes lots of languages. So multi-language support is becoming more of a standard, but the way each model treats different languages is not the same. So if multi-language support is important for your use case, then you have to factor in evaluating in different languages as well, beyond just English or your native language. And then, the chunking stuff we talked about, thinking through how do you actually parse documents of different types. There's different tools to help you, handle PDFs, convert them into text, and then the embedding model will take that text and convert it into embeddings. There's all the chunk size considerations, et cetera, based on your context window and again, your use case. Ultimately, all these decisions, you can use kind of heuristics and like we talked about, but the most important thing is evaluating the end-to-end system. Once you're done, once you build your RAG system, is it actually improving the generation quality, and having evaluation metrics for that, especially as you iterate on these things, is really important, so that you can compare for each of your settings of chunk size, of embedding model, of LLM model, of do I go multi-language or not, etc. You want to see quantitative results for your given use case. And so being able to evaluate the end-to-end solution, I think, is the most important thing, to think through how you're going to do that. And we can provide some tools to help our customers do that, which is really exciting, because it gets complicated fast, as you heard us talk about all the different components you need to think through when thinking about solutions like RAG.
The majority of our conversation and the majority of the conversation across the ecosystem right now is focused on text and natural language, but there has also been an increase in the desire and application of multimodal models, or models of different modalities than just text. And I'm wondering how that impacts the ways that you even can do chunking, where it doesn't necessarily make sense to chunk an image because the image is kind of the entirety of the thing that you're asking for, and maybe then you have to go to downscaling the image to reduce the size and quality, or if you're dealing with audio or video data, how does that influence the applicability of RAG and the ways that you think about that context retrieval?
Yeah, absolutely. I think the trend is definitely going multimodal. And I think in the next kind of year or two, it'll be rare that we have a unimodal model. I think every model is going to end up being multimodal just because the more different types of data that these models can learn from, the smarter they can get. And when you think about it, it's kind of how humans learn. Like I have a young child, and just seeing him learn every single day is really interesting because he can't speak yet. He understands some words, but he can see, he can hear, he can feel. Like it's all different modalities of data that he's clearly learning from. And my older daughter has gone through that stage, and she's still learning in a variety of different ways from multiple different data types. And so it's very obvious that these models are only going to get smarter because they learn from multiple modalities. And how that affects RAG is that you got to think about the chunking, as you mentioned. Typically, the way these transformers work beyond text is that everything gets tokenized. So text is tokenized by taking a few characters and converting it into a token. In images, you take patches of pixels and convert them into tokens. Similar for audio, you chunk up the audio. And so all of it becomes tokens, and then they're just fed into this giant transformer model that can understand the context and attention amongst all this kind of soup of different modalities of tokens. And that's what allows different multimodal models to take in not just one image and text, but it could be just a list of multiple different data types. Like, and you can do cool use cases like what's going on between what are the differences between these two images, or give me an audio clip that like represents this picture. You can do really cool multimodal stuff with on the generation side and the Q&A side. And that has to factor into all the different components within the RAG system because you have to embed all the different data types, ideally into one common embedding space, so that when you get a query, you can retrieve in all the different types of data that are relevant, and then they get tokenized and fed into the large multimodal model. And then the same process that we walk through with text-only RAG of evaluating the end-to-end system is really crucial. We're starting to see more and more benchmarks for multimodal, but I think it's definitely like a year and a half or so behind the text large language model benchmarks. And so I think that's going to be a trend we'll all benefit from and see, is just much more high quality data sets to give you the general purpose kind of evaluation benchmarks, and then more tools to help you evaluate multimodal flows like RAG on your particular data sets.
So we have talked through the embedding piece, thinking about how to strategize that, the considerations that go into it. The next layer of RAG is the vector database, as we've already discussed. For the purposes of retrieval augmented generation, what are the features of a vector store that are most critical, and some of the evaluation criteria for figuring out which one of these vector databases versus vector indexes, et cetera, you actually want to include in your architecture?
Yeah, this is another place where there's lots of different choices. I think in the last 20 months, there's like 50 different vector databases you could choose from. I don't think that's going to continue. I think there's going to be a lot of consolidation, which is going to be easier to stand up a vector DB in the future. But you have choices like, do you want to use the vector store that's already in the database you're using? So I was just looking at this. There's a really good report that I think your viewers would love flipping through from Retool. It's the State of AI report that I think just came out. And they have like a list of the most popular vector databases. And it was like PG Vector, which is an extension to Postgres, is most popular. MongoDB is up there, Pinecone's up there, etc. And with Postgres, Elastic's up there as well. So like with Postgres, MongoDB, and Elastic, it's kind of obvious why they're up there. It's because it's just a feature on your existing database. And that's just a huge convenience rather than having a place where you store your data today and then having a completely different vector store. And that's actually honestly how Clarifai always looked at it. We may be the first production vector database. We launched it in 2016, and it was always built natively with all the other data that you're storing in our platform so that you can, and this is a criteria that you should evaluate vector stores with, can you do the queries that you want to do in addition and kind of joining with the vector queries. So filtering by metadata, we let people do searching by AI labels, by what the AI is predicting, as well as combining with vector stores all in one kind of query. And most vector DBs kind of focus just on the vector part, making that good, and not doing the joins with other queries that would be really useful for the overall query that you want to make. And that even in a RAG situation, that becomes really important because back to kind of what we talked about earlier about access control, how would you actually filter by what permissions a user has to the data without having that additional kind of join? You could do kind of, joins in memory and all that stuff between different data sources, but that's prone to bugs and inefficiencies. So having a vector store that has all the filtering you need in one place is really important. And then for vector store specific features, latency is obviously important. For use cases like RAG, though, it's not, I would argue it's not like the most important thing because at the end of the day, these large language models and large multimodal models are slow. And especially when you have all the retrieved context that you're going to stuff their context window with, it's pretty slow to generate. And so having a little bit slower latency won't actually impact the overall system latency that much because it's not going to really dominate compared to the generation. Obviously, faster is better, but I think when people are choosing vector stores, that can take a lower priority. I think how does it handle scale is important. Can you stuff in lots of data? And when that happens, does it kind of get distributed beyond a single node to handle failover and scale? Those become really important. How does it handle the different dimensionality of your embedding vectors? We talked, so some of them have limits on it only handles 1,024 dimensions. It can't do 2,048. Stuff like that can actually cap you on RAG because your embedding model that you want to use might not actually be able to fit its embeddings into the vector store. And then there's all the different kind of indexing. How does it index? Is it accurate on retrieval and precision? Is it efficient to do that retrieval? Can it quantize the embeddings and still keep that index performance high? When people think about the vector store quantization, this is actually like seeing this whole market of vector stores come out, and quantization is like a hot new feature. We literally had that in 2016, and me and a couple of engineers actually wrote that code. And it's the same techniques that people are kind of inventing now today. But we did it because it saves a ton of memory in your vector store. Taking a 32-bit precision floating point number, which is typically what these models will output, and crushing it down to 8 bits or 4 bits because the range of these numbers isn't that big. And sometimes you don't even care about negative numbers because the models often output only positive numbers in their layers. So you can actually get rid of lots of bits by thinking about the data and looking at kind of distributions of these values. And so the quantization can take a 32-bit number down to just a few bits. There's even results where you can actually do binary, just zeros and ones for all the values in the embedding vector. So you can get a 32 times reduction in the memory used with a trade-off on how accurate those binary vectors are going to be at the end of the day. And not every vector database supports that kind of binary embeddings. They don't all support 4-bit, 8-bit. Many would support, all of them would support 32-bit, but many of them would support 16-bit floats. So that quantization becomes really important because it's memory and the retrieval latency and the accuracy all get affected by that quantization process. And there's also like benchmarks for these vector stores. It's another area where you can look at a lot of these metrics. I haven't seen that many good independent benchmarks, unfortunately. When you search for this, I was actually just literally doing this morning. When you search for like benchmarks of PG vector versus Pinecone or Quadrant or Milvus, there's lots of these vector DBs. They're often written by one of those providers. And so it's a little bit like the provider of any tool is going to know their tool better than anyone else. And so they're going to make sure the benchmarks are really optimized, really working well. And then they're going to use kind of default settings for all the other providers. And so I haven't seen a good, like, ground truth, independent benchmark. If anybody knows, I'd love to see that. But I think that would really help the vector store decision process.
The maybe not the final decision, but I think the next large decision to be made in your RAG stack is what model you're actually going to use to do the generation. Obviously, this is a very fast moving target. It seems like there's a new model every week, or at least tweaked versions of the same set of models that are coming out on a day to day basis. What are the foundational aspects of a model that you look to when you're deciding which one you actually want to apply to a given problem domain?
Yeah, again, it comes down to some of these open benchmarks. There's, open LLM benchmark and a lot of these leaderboards you'll see online. So that's a good place to start because those are typically where any model provider is going to want to showcase their model on these standard general purpose benchmarks. But again, those are typically good for the general purpose use cases, which will cover a lot of ground, like writing emails or chatbots. And we're starting to see kind of leaderboards and evaluation benchmarks that are becoming more specific. I think I just saw one about CRMs. So if you're wanting to, interact with your Salesforce, HubSpot, Pipedrive, et cetera, CRM, and that data is very specific to sales and marketing activities. An LLM that's trained on that data is likely going to perform much better. And so, again, it starts with your use case, decide on what you want it to be good at, and then find the most appropriate benchmark. And it'll give you an idea of accuracy. Then there's the notion of how big the generative model is and where you're going to host that thing. Is it going to fit into compute that you already have? Does that compute auto scale? All the production grade inference becomes really, really important with this model, because typically the embedding models are smaller than the generation models that are used in a RAG system. And you don't always need the biggest model. I think people kind of default to the big third party models, and for most use cases they're likely overkill. And for RAG use cases in particular, because you're getting that additional help from the retrieval to augment the generation, it doesn't need the best model that has a trillion parameters and has memorized the entire internet, because you're actually getting the data that you need to generate with stuffed into your context window. So a smaller model can actually get those facts that are stuffed in, and pretty much all the small models are really good at writing English and many other languages at this point. And so the task of RAG is much more well defined and constrained, so a smaller model can perform well. And that'll give you improvements, not just how costly it is to run these things, but also the latency. The bigger the model, typically the slower it's going to be. And it also kind of limits a little bit the ability for the models to kind of hallucinate and go off the rails. So that trust and safety and evaluating the whole end to end comes into play again. And there's another dimension to choosing the generative model. Hopefully the RAG pipeline is going to end up kind of addressing the hallucinations and the trust and safety concerns. But some models that have never been trained on, offensive words are just not going to be able to, generate that kind of content, as an example. And so depending on your use case, you may want that or you may not want that. And that can be another dimension of trust and safety you have to think through in choosing your generative model.
One of the interesting side effects of all of this interest in generative AI, RAG, is that growth in vector databases, vector indexes, and those have started to be repurposed towards semantic search. I'm wondering, what are some of the other ways that this investment in RAG capabilities is able to be repurposed for other use cases?
Yeah, and this is actually why when we launched vector database in Clarifai, we never actually called it a vector database. We never marketed it at that. We never actually anticipated the world to have this vocabulary of talking about embeddings and quantization of them and all these LLM choices. Like that kind of changed overnight when ChatGPT happened. So when we created it, our vector database, it was never for RAG. It was for things like visual similarity search. So you have an example of a product in front of you that you want to buy, like a nice chair or something, and you use that image to query a product catalog to find the most similar looking chairs to buy online. So that's a great kind of use case for similarity search. Same thing happens with text. It's the exact same process that happens in the retrieval step of RAG, just stopping there. I have a snippet of text. Do I have any similar snippets of text? This is useful in general for content organization. So we work a lot with marketing teams, as an example. They have all their visual content, they have all their text content indexed into Clarifai, and people can very easily in the search bar type in a query and find similar content to that query automatically without kind of writing code and all that and stitching all these components together. And that's a huge value add. And that comes into play in all these kind of intelligence community applications as well. Lots of use cases for similarity search, like a vehicle, for example. You think you've seen that in security camera footage before, and you want to check, so you can use the query being the vehicle and match it in a large database. And then the other kind of bucket of use cases beyond the similarity search is just deduplicating data. So this happens, and this can be done, like think of duplicate images. You can, one technique is to just match the pixels, but then it has to be exactly the same image. And that's not very reliable. Even just changing the compression settings on an image will change the pixels, even though they look visually the same to our eyes. And so having the images embedded and then comparing at a high level understanding of the images is very effective at deduplicating data, because you can actually find similarities in clusters and say, oh, all these are derived from the same image, or they're duplicates. And when you do these matches in vector stores, you actually get a score typically of how similar things are. You can use that score to get how confident you are that these are exact duplicates, near duplicates, or not duplicates at all. And so, going back to some of the business use cases for that, it's like the marketing team buys stock photos all the time, and now a lot of those are generative. Or do they already have one that looks like this? Do they need to go buy a new one? That deduplication has a real kind of dollar value directly attached to it. So it becomes really powerful having a vector store for these other use cases, and RAG just kind of came about as one additional newer use case for these generative models.
In your experience of working in this space, supporting these RAG use cases, building the functionality in your platform to manage that end-to-end flow, what are some of the most interesting or innovative or unexpected ways that you've seen those techniques used?
Yeah, I mean, there's so many. Um, I don't know. Maybe I'll start with the least innovative, I guess. I'm seeing just so many like chat experiences added to products, and I think that's going to be a fad, and maybe it's already fading away. But I think those types of use cases are suitable when you already have a chat experience, like a customer service bot on your website. Like that totally makes sense. But just injecting a chat window to have people like interact with things that are never meant to be interacted with in a single box is a decrease in user experience. So I'm actually like not a big fan of those types of RAG use cases. When it is a scenario where you already have a search bar and that is a natural thing, whether it's internet search, whether it's We use Confluence for our internal documentation and Google Drive. Those types of searches can all be improved very, very significantly with these components that you need for RAG. And then the next step of just retrieving the documents off the search is to start summarizing them. And we're starting to see that kind of even internally. You see it obviously when you search on Google, and I believe Bing as well at this point. They're all kind of summarizing, depending on your query, of course. Ones that are already indexed, they're summarizing a good summary so you don't have to click through all the results. And that's just a huge productivity gain for everybody. When I think of kind of some of the most interesting applications of this, or the highest value applications, maybe, it's where the people having to do those traditional search and read and summarize tasks are in high demand. They're kind of domain experts in their field. That might be, intelligence analysts in the intelligence community, doctors in the medical community, lawyers in the legal space, financial analysts, etc. That's where these productivity gains are really unlocking business value. And when you think of some of these domains, that's the ones I listed, they're kind of the domains that are least likely to have been trained into the model in the first place. And so solutions like RAG, where you can ground it with, factual stuff like medical textbooks, or, all the financial 10Ks of the quarter, etc., all the classified documents in an archive, that's when RAG really unlocks the biggest ROI beyond having a generative model alone. So I think those are the most exciting use cases I've seen RAG for.
And in your experience of working in this space, being in the ML community for so long, as generative AI has really started to take all of the attention away from other applications of machine learning, what are some of the most interesting or unexpected or challenging lessons that you've learned personally?
Yeah, I mean, the gap between prototype and production, I think, is just surprising, and I almost feel like it's getting bigger kind of as the field continues to have lots of new things every day, lots of continued innovation. People can get up and running easier, so the prototype is becoming faster, but getting into production is a huge undertaking, and I think people often underestimate that. We like to talk about that as the false finish line. People like get a use case in their company up and running. It might be on your laptop. It's pretty easy to do that, even with solutions like RAG. But then thinking about those day two operations of running in production, not just getting to production, but how do you keep it up 24/7 with many nines uptime? How do you do that cost effectively? How do you have those access controls scaling up, scaling down, etc.? How do you keep that up to date with state of the art? How do you do that in a way that you're not, constantly in a procurement mode and reviewing security posture of every vendor you're choosing because they're all different for the stack? How do you have tests if you're cobbling together the stack? How do you have tests that make sure it's going to maintain its kind of stitched together state over time as vendors change their APIs or new things come out? It becomes a huge undertaking going from prototype to production, and that just continues to be surprising because when we talk to a lot of different customers, they have this default mindset that they need to build the stack themselves, and everybody's spending like 75 to 80% of their time building tools for AI rather than building AI into their business. And I think that's just a huge mistake, and something that we've seen before with the cloud transformation. People like HashiCorp built a bunch of great developer tools that helped with the cloud transformation. And the companies that adopted those tools accelerated, and the ones that didn't ended up spending their time reinventing the wheel, building tools themselves, and lagged. And the same thing's happening and repeating itself in the AI space. And that's actually what kind of excited a bunch of new executives joining Clarifai from HashiCorp and Cohesity and UiPath and a bunch of other great companies, because they see what we're doing here of accelerating developers from prototype to production in enterprises is exactly the same kind of playbook that was successful in the cloud transformation and really helped empower users to kind of become heroes in their business. So we want to make a lot of developers into AI heroes with our platform.
To that point, there's always a gradient of I can throw together a prototype really quickly, but I don't actually understand what's happening, to I'm a subject matter expert in this case machine learning, but maybe I don't have all of the operational capabilities. What is the level of domain knowledge and expertise in that context of machine learning and AI that's necessary to be able to effectively apply these AI models and RAG stacks to a problem domain and build a product around it?
That's such a good point. Yeah, I think there's a lot of tools like Clarifai that abstract away all the complexities and make it really easy. And I think that lowers the barrier to entry a lot in adopting AI. And so, some concrete examples are in the intelligence community, we actually have intelligence analysts themselves using our platform. Our platforms, the APIs that power all the backend, really easy to use SDKs for developers to get up and running, doing RAG and 5 lines of code, for example. But then on top of that is user interfaces that make it literally a few clicks to configure a RAG system or do search queries over your data, train a model at the click of a button, manage your data sets, etc. And so that's where you don't have to have a PhD in AI like I do. You don't have to be a developer even. You can actually start getting the benefits of AI with just a few clicks. And I think that all depends on your stack. If you're going the route of stitching together a bunch of tools, you're really the domain experts can't use it. It's too complicated. The developers are spending most of their time stitching together tools, maintaining them. Probably never going to write tests, so it's going to be brittle. And the data scientists may come into play there, kind of just customizing some of the stack, but all of it's not going to be as customizable as they really want. So it's kind of not good for anybody. So choosing the right set of tools really helps kind of democratize the experience around AI.
And for people who want to take advantage of all of these new AI capabilities, what are the cases where RAG is the wrong choice? And maybe you just want to go with prompt engineering or use the out of the box model, or you need to go down one of the other roads of fine tuning or building your own model from scratch.
Yeah, so I think these general purpose use cases are pretty effective, like taking a bunch of text and summarizing it, just continuing to generate like prompt engineer to tell me a bedtime story for my daughter. Those types of things, like the information that's trained into the model from the internet is good enough, and actually kind of what you want. So doing RAG in those scenarios is going to be the wrong choice. You really want to use RAG when you have custom data and you want to ground to prevent hallucinations as much as possible. When you're actually generating like a bedtime story, you kind of actually want hallucinations. So it's a good example where RAG would actually be hurtful to performance. Doing creative work like generating writing samples, generating advertisements, writing your emails, those types of things. RAG may not be the best choice. Unless you really need to get something very specific, like it has to be advertised in this certain message, or you wanted to write emails exactly like you do and not any better than you do, which these models can typically do now. It's really that level of customization that is going to dictate when you want to use RAG or not. And that's also true for fine tuning and pre-training models as well. Prompt engineering should generally be the kind of where you start for a use case, and then you can see if it's good enough or not.
As you continue to work in this space, work with your customers, stay abreast of the latest trends and developments, what are your predictions or aspects of the ecosystem that you're keeping a close eye on and getting most excited by?
Yeah, I think we talked about this a little bit. This notion of consolidation, I think, is going to happen. There's just too many different options at every layer of the stack. Vector databases, we mentioned this. There's like 50 different vector databases, and it's not just an AI thing. Like no market can support that much variety. So I think a lot of this is going to be consolidated into offerings that provide multiple different components in one place. Right now, it just feels very disjoint in you know the whole pipeline you need for these more complicated use cases like RAG. The data prep tools, transformation of data, integrations with your data sources, the prompt engineering tools, the vector database, the embedders, the LLMs. Like there's lots of different components, evaluation metrics and leaderboards, etc. So consolidating where all that just works out of the box as a workflow. That's why we're calling Clarifai the AI workflow orchestration platform, because we actually help people do a use case like RAG very, very quickly. And so I think that's going to be a trend. We talked about the multimodal as well. I think that's an obvious trend. And models like the GPT-4o are really interesting because they're blending the modalities kind of in real time. And I think that's going to be a continued trend as well. It's going to open up a lot of experiences that are much more natural to communicate with these models than the chat window we talked about before, or kind of a high latency experience in other approaches. So I think that's going to be a continued trend. And then I think just more and more ease of use. Everybody talking about embedding models and getting excited about the next new LLM coming out and all that kind of stuff. I think it's going to move to the background pretty soon. And people are just going to be like, how do I use this? How do I use it in production in the easiest possible way? I don't care about all these details. I just want it to work. I think that's going to be a trend as well.
Are there any aspects of the overall space of retrieval augmented generation, applications of these generative models, the work that you're doing at Clarifai that we didn't discuss yet that you'd like to cover before we close out the show?
No, I think we covered a lot today. It was a great overview. Hopefully that was helpful for everybody listening.
Absolutely. And for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest barrier to adoption for machine learning and AI today.
Yeah, I think it's a lot about what we talked about today, just how disjoint the ecosystem is, and that's leading to difficulty going beyond that prototype into production. So I hope people test out clarifai.com. You can sign up for free, get started, and you'll see the difference of how having all the tools in one place can help accelerate you all the way to production.
All right. Well, thank you very much for taking the time today to join me and share your experience and perspectives on retrieval augmented generation and the considerations that go into the different layers of those stacks. It's definitely great to learn a bit more about those concepts, the technologies involved, the business questions involved. So I appreciate you taking the time today, and hope you enjoy the rest of your evening.
Thank you. Thanks for having me.
Thank you for listening. Don't forget to check out our other shows. The Data Engineering Podcast covers the latest on modern data management, and Podcast.init covers the Python language, its community, and the innovative ways it is being used. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at aiengineeringpodcast.com with your story.